Hello everyone, I am Professor Gautam Moon from the Tulsi Ramji Gaikwad Patil College of Engineering, Mogaon, Nagpur. I am currently working as an assistant professor from the Tulsi Ramji Gaikwad Patil College of Engineering, Nagpur, from the Department of Electronics and Communication Engineering. I am delivering a lecture on VLSI testing. The subject of it is a uh, seventh semester from Electronics and Communication branch. First of all, the introduction of the VLSI testing. The VLSI testing means very large scale integration testing is the process of checking whether the integrated circuit functions correctly after manufacturing and during operation. We know that the as a modern chip contains millions and billions of transistors. Therefore, the testing has become the very important and critical part of the for the semiconductor design and production. So the main objectives of the VLSI testing is to detect fault, ensures reliability, improves quality and control, and mainly to reduce the manufacturing cost. So the VLSI testing is the process of verifying that the manufactured chips functions correctly and meet design specification. We know that the chip manufacturing can introduce the defects, but the testing helps identify the faulty chips before reach to the customer. So testing is very important in the VLSI semiconductor design and production. Also, there are many advantages of the VLSI testing that defective chips causes the many problems in the VLSI circuit, but the testing helps to identify that faulty chips and increases the reliability. Also, effective testing saves the time and money by catching the faults early. So, testing is very important in the VLSI production cycle. Now, we have to discuss some importance of the VLSI testing. Importance of VLSI testing. There are some importance of the VLSI testing. First, detection of manufacturing defects. First of all, the first importance is the detection of manufacturing defects. Now, during the fabrication, during chip fabrication, there are some defects can occur. That is the open circuit, short circuit, missing connection, bridging fault, also oxide breakdown. So these are due to the imperfections are occurred during the VLSI manufacturing process. So for this, the testing is very important. Testing helps to identify these faulty chips before they reach to the customer. So testing is important. This is the first point. Second point is ensures correct functionality. Ensures correct functionality. The VLSI testing, the VLSI circuits are very important, and the VLSI testing verifies the some points, that is logical correctness. First, logical correctness. Second, timing behavior. Timing behavior. Third, power consumption. and fourth, signal integrity. So by using these guarantees that the chip works properly under different operating conditions. So testing is very important to ensure correct functionality. Now third is the improves reliability and quality. The testing increases the reliability and quality of the electronic system that is used in the computers, laptops, mobile phones, also medical equipments, also automotive electronics, and aerospace system. So the fault in such application can lead to the serious failure. Therefore, testing is very essential for this purpose. So testing is very important. Next, to reduce the cost, reduces the cost. So testing also helps to reduce the cost. Now, detection of the faults early in the production is cheaper than the repairing the system after deployment. Uh, means detection is very important as compared to the repairing system after deployment. It reduces the warranty cost. It reduces the warranty cost. Also, to avoid product recall, and third, to increases the yield. YILD. So by using testing, it reduces the cost. Next, fifth, it supports high complexity of modern ICs. High complexity of modern ICs. Now we know that the modern chips having the complex circuit. There is very complex circuits are there. It contains some multi-core processors, second embedded system. Also there is a memory block. So modern chips having the very high complex circuit. Therefore, the manual testing is impossible to detect. Therefore, it should have the advanced testing technique. Therefore, the testing is very important for the uh, to support high complexity of modern ICs. Next, increases yield, increases yield, yield. Now what is meant by yield? Yield refers to the percentage of the manufacturing chips that functions correctly out of the total number of manufacturing chips. That is known as the yield. So higher yield leads to the greater profitability. Therefore, for this yield, the testing is very important. Next, essential for essential for safety critical applications. Safety critical applications. Now, in industries such as automotive, defense, aerospace, also medical electronics, so even a small fault can cause a catastrophic failure. Therefore, a rigorous VLSI testing is very important. Therefore, this testing is very important in VLSI circuit. So these are the points I have covered, the importance of the VLSI testing. Next, we have to discuss the types of the faults. Next, we have to discuss types of the faults. Types of faults. In VLSI testing, the types of faults is very important. Therefore, there are three main types of the fault. First is the permanent fault. Permanent fault. Second, intermittent fault. Fault. And third, transient fault. Transient fault. So these three faults are very important. So first we have to discuss the permanent fault. Permanent fault, it is a continuous irreversible physical damage that remains in the chip forever until the component is replaced. Now permanent fault, these type of faults can occur. It is caused due to these faults are caused by the manufacturing defects such as open circuit, short circuit, then missing components in the circuit, then oxide breakdown, then also bridging faults. So these are the causes of the permanent fault. Now these faults are easily detected during the initial stages of the testing, that is designed for testability. Means detection is during initial stages of testing, that is designed for testability, that is the DFT. So this is the permanent fault, and for example, the permanent fault, example of permanent fault is a signal line is permanently stuck at logic 0 or 1. A signal line is permanently stuck at logic 0 and 1. Second, intermittent fault. Second, intermittent fault. So intermittent fault, these faults occur at irreversible interval, that is appearing and disappearing repeatedly. Therefore, and these types of faults can be caused by the first caused by these type of faults can be caused by the unstable hardware. Then environmental variations such as temperature spikes, then loose connections, power supply fluctuations, power supply fluctuations, then also mechanical vibrations. So these are the causes of the intermittent fault. And detection, so the detection is very difficult because it depends on the specific operational condition. So because it requires some continuous online monitoring, therefore this detection is very difficult. It requires continuous online monitoring. And the example of the intermittent fault is a connection that fails when the chip temperature becomes high. Agar when chip temperature increases, then the connection will be loose or disconnected. Now third fault is the transient fault. Transient fault is the temporary fault. That is the one time error. It is also called the soft errors. It is also called soft errors. That it is also called the soft errors that corrupt the data or logic states, but it does not corrupt the physical hardware. Therefore, this is known as the transient fault, that is known as the temporary fault. It is also known as the soft errors. And these faults are caused by the external environmental interference, that is the cosmic rays, alpha particles, and electromagnetic interference. So these are transient fault is caused by these three ways. These are the external environmental interference: cosmic rays, alpha particles, and electromagnetic interference. Also, detection. So these transient faults are detected during the runtime. So these faults are detected during the runtime, and these faults are detected during runtime. These are easily resolved by by correcting the code, that is the error correcting code memory, rewriting the memory bit. And the example of this transient fault is example is a memory bit flips from 0 to 1. A memory bit flips from flips from 0 to 1. So that brings us to end of the today's lecture. Thank you everyone.